is going to be some discussion using trig identities. So today we're going to be proving one of the problems on your worksheet. So this is your problem. So we need to prove tan of x cosecant x equals sec x. Now, here's what I need you to remember. We have a whole bunch of these rules here, right? And I'm going to tell you, when we're solving for problems that you see here, what we tend to want to do is we want to turn the left side into the right side, or change everything into coses and sines in order to make sure that everything is equal. So it's kind of like you're turning the left into the right, and then if you realize that the left is not quite the right, you go to the right and then turn the right into the left to make both of them equal, and then you're good to go. So let's go and do that with this problem. So for the left side of the equation, we have tan x cosecant x. So let's just write that out. Now, based on what we know that tan is the same as sine over cos, and cosecant is just 1 over sine. So let's just write that out right now. So now, sine x cancels with sine x, and then we're left with 1 over cosine x, which is the same as, well, if you look here, cosine is the same as 1 over sec x, which means sec x is equal to 1 over cos. So this means 1 over cos is this. Now, since the left side equals the right side, therefore quod erat demonstratum. We're done. And that's pretty much it. So now let's move on to the next problem. Alright, for this problem, we want to take something that's on the left side and turn it into the right side. And in order to do that, we're going to have to use something like, anytime you see squareds, we tend to want to look at the Pythagorean identity, right? Now, I'm going to go and try to manipulate the left side and turn it into the right side. So, when you're looking at sine plus cos equaling 1, I could rewrite this as sine squared theta equals 1 minus cos squared theta. And then based on that, we can go and do like some crazy mathematics to come up with what we want. Because we can also say that, well, sine squared theta plus cos squared theta is 1, and then kind of manipulate. So let's go and do that right now. So let's go and take a look at the left side of the equation. And now, you notice sine squared x minus 1. Well, we take a look at the Pythagorean identity, and you realize that sine squared x plus cos squared x equals 1, which means if I solve for sine squared x, it's going to be 1 minus cos squared x. And that's what we have right here. So now that I've got that, I'm going to take what I've learned, and I'm going to sub it right into here. So now, you're going to get the following. Wow, that's crazy. So now that you've got that, what you're going to do is you're going to distribute the 2 into this little problem set, right? And you end up with something that looks like this. Well, 2 minus 2 cos squared x minus 1, right? which is just the following, isn't it? 1 minus 2 cos squared x, yes? But we know this is true, yeah? 1 is equal to cos squared x plus sine squared x. So 1 turns into the following. Cos squared x plus sine squared x. And that's literally all of this. Is that just one number there? And then we just write minus 2 cos squared x. So I have a cos squared x and a minus 2 cos squared x. Well, that just turns into minus cos squared x, which is what we want. And then we're left with sine x, and that's just sine squared x. Hey, it works. The left side equals the right side. Therefore, quad erat demonstratum. We're done.